Okay, next, I want to talk about some of the services. I'm going to try to go quickly because I would like really to reserve some time for the analytics discussion, network performance management that Steve has. So I'm going to try to cover this rapidly. So scalable and automated overlay fabric. What do I mean by that? Let me talk first about automation, the 3 levels of automation we have into these systems, right? Number 1, the fabric underlay automation. This is how you automate the build out of your BGP fabric or whatever it is, right? BGP fabric, OSPF fabric, layer 2 fabric. You have to automate that. And for that, we have tools, which I'm going to talk about in a moment. I'm going to talk about our own tool, our own management tool for that, but you can use Ansible at the same time. This is actually, frankly, table stakes. It's expected these days, right? That you have the capability of automating fabric. I'm going to point out in a moment, however, where I think we put a lot of effort on, which is automating in an environment which is a mixed environment, right? Because again, we keep showing pictures where Pluribus doesn't sit here. We'd love to sit here, but the reality is many customers are not ripping out their entire spine or core layer. And automating an environment where you don't control the other side is actually challenging. We put a lot of effort into the underlay automation where it's kind of free. In the sense, we give you freedom of choice, but then we have to deal with that, right? Because one guy can have ERP, the other guy can have BFD, the other guy can have BGP. All these options at the underlay need to be accounted for. So a lot of effort goes into automating an heterogeneous environment, right? Second, we have a level of automation which comes from, I call it here, edge ports automation. The classic example of vCenter provisioning VMs, attaching VMs to port groups, and then the VLANs gets provisioned, the lags, et cetera, provisioned. This is obvious, right? It's, again, table stakes, right? But the interesting part is that upon provisioning the edge ports, or the VM facing port, or let's say the customer workload facing ports, we automate in the backend the underlay, and this is totally transparent to the customer. So we use our fabric intelligence, the VTEP awareness, the vPort awareness that we have discussed early on, to actually create an overlay fabric which is fully automated to the customer. So the customer only has to worry about standing up a new VM, a new service, provisioning a front panel port with a VLAN, and then we take care of provisioning the overlay network on top. The underlay, I consider it as a day one operation to stand up your underlay network. But then there's a level of dynamicity, if you will, if you allow me the term, when you provision your workloads and applications. Then you need to have the overlay capable of reacting. It's an event-driven automation on the underlay. Now let me actually look at these 3 types of automation. The underlay. So Steve alluded to this tool we built. It's a Fabric Manager, which we call UNUM, Pluribus UNUM Fabric Manager. This tool is actually pretty powerful in that it allows you to automate an infrastructure where it can be Pluribus leaf and Pluribus spine, third-party spine and Pluribus leaf, Pluribus spine and third-party leaf with layer 2 and layer 3 protocols, at least the major ones, right? From MST to VRP to BFD, BGP, all these classic protocols. And you select a menu, I have a menu of options to build this underlay, right? It's not one leaf and spine, one protocol. We give you flexibility for all layer 2, layer 3 capabilities.
I just got to pick the one I intend.
Yes. Yes, exactly.
But if you pick the wrong one, we can change it really quick.
Yeah.
So, but again, a lot of effort in automating a heterogeneous environment. But in the end, okay, it's cool, it's interesting, but it's not really unique. What is more interesting is actually what we do with the overlay, which is triggered by the way we provision edge ports. Clearly, you can use vCenter to drive from vCenter itself the provisioning of VLANs and ports and lags on what they call it, the edge ports, or it can also be manual, or you can have your own orchestration system and through REST API issue commands on the fabric. But what's really interesting is actually what we do on the overlay side. Across all the leaf, we build VTEPs, and all these VTEPs automatically build a mesh of tunnels. So you don't have to worry about building tunnels. You build the VTEP, the tunnels come up automatically. As soon as the moment you assign a VLAN to a physical port on the switch, automatically we stand up the entire L2 segment across the entire infrastructure. So taking care of mapping VLAN to VNIs, assigning VNIs automatically, mapping VNIs to VTEPs and then to tunnels. All this sequence is actually taken care on demand and dynamically on behalf of the customer. Customer only has to worry about provisioning the front panel ports. And then once we have this sort of overlay infrastructure in place, we talked about the conversational forwarding because we have vPort awareness or endpoint awareness. So we can actually place a nice optimization in the way the traffic flows and we optimize traffic. And also we consume resources, right? Because you won't want to consume hardware resources if these conversations are really taking place. You don't want to necessarily blast routes, host routes everywhere if this conversation don't really take care of. ARP optimization we discussed, and then of course, to avoid hairpinning, we have this Anycast gateway function associated to each subnet, which is also pretty interesting. So again,
it looks like you moved past automation, just a question of automation.
Yeah.
You do have modules for Ansible and Napalm, right?
Ansible.
Okay.
Yes, we have spent enormous effort on the Ansible side. Right, that's our automation framework. And again, to be honest, our tool is actually using Ansible under the cover. Right? So the language of playbooks is actually what you'll find as you use our GUI. It's just GUI driven. The Ansible server is built into our tool. You don't have to worry about that.
So you built your own Ansible tower.
Yes, we built a GUI front end to an Ansible. Exactly, exactly right.
Two questions real quick.
Sure.
The VMware integration you had earlier, was that Sans NSX or just NSX VTEP integration, or is that like a plugin and just kicking your API or something?
Yeah, exactly. So we have two levels of integration. One is with the standard vCenter, right? So you stand up an ESXi server, the ports are provisioned. With the lags, we look at the teaming configuration on the server, that basic stuff. Then you create a VM, you associate the VM to a port group, the VLANs belonging to the port group are now programmed into the fabric. That triggers the automation, the VNI, the VLAN to VNI, etc., mapping on the overlay. Then we have, and this is one realm, if you will. Then we have the integration with NSX.
And then you guys are hardware.
That actually, we are just a traditional layer 2 gateway. Right? You can find it on any vendor, but there is a function that we have developed as well. Right?
So your OVSDB gateway.
We have an We have an OVSDB gateway. We use this for ODL. We have an integration with Ericsson, one partner for ODL, and then we use the same facility
for NSX. That thing hasn't died yet.
Huh?
ODL hasn't died yet.
And then the second question, just between VTEPs, is it all unicast?
I still love
because,
it.
in a spine leaf would be multicast problem.
You can have multicast, layer 2 multicast, layer 3 multicast.
Even if you have third-party spine?
Yes.
And so you just integrate, play nice with multicast?
Yes. Again, the beauty of what we're trying to accomplish is that we don't want to dictate the way you build your network, right? Sure. Imagine I go to a service provider customer which is running PMSSM, and they say, no, you can't do it because my fabric. Then you're out, right? You have to fit. It's about fitting. So yes, we're developing all these layer 3 multicast protocols, IPv6, V4 over V6 stack. All this infrastructure is the underlay.
And can you unicast if you had something crappy in the middle, like for spine layer that was just, or if there was no multicast, could you unicast it out to all of the other leaves instead of having like a multicast stream? Like
do you do head-end replication of logic?
No. Okay.
Well, we do head-end replication for VXLAN.
Yeah.
We do that. Yes.
Right. Yeah.
That's what you meant?
Yeah.
Yes, we do have head-end replication, of course. Yes.
Cool.
So which is synchronous replication? I assume you don't do any multicast optimization.
No.
Yeah, so I have a different variant of this question that I've been mulling over for the last 5 minutes, which is, Okay, how does this different from what NSX is doing? And I've seen some environments where people tried, for example, to mix ACI, Cisco ACI with NSX. And so I was sort of seeing VTEP and thinking, okay,
No,
this...
but hold on.
Well,
hold
let
on.
me finish the long-winded question. It was sort of sounding like, okay, this is sort of like NSX with a lot of hardware mixed in. Physical servers, physical devices, as opposed to virtualized devices. And so is there a use case when your network is, let's say, 90% virtualized?
So let me clarify.
Yeah.
At the fundamental level, we are complementing NSX because we run on a physical switch, right? NSX runs on an ESXi host server. So we don't touch servers here at all. Servers are connected to our fabric, and our software only lives on network switches. That's the fundamental difference, right? So we are an underlay. When NSX comes to play, we're an underlay.
But all you need is a ordinary fabric underlay. You don't need all this extra machinery.
Exactly. NSX removes some of the benefits that we have, but again, you always have a mixed environment, right? I mean, networks are typically mixed, right? So what you can use is NSX on a portion of the network, and then through the gateway functionality, extend the control of NSX in a way, or the properties of NSX through the Pluribus fabric to a bare metal environment, for example.
There's two ways to look at it, right? A customer wants to take advantage of NSX, and they're going to build a basic network to do that and run the whole virtualized on top. And they're going to go for the simplest of choices. Some people are doing it on ACI or others. Same in our environment. We give the added services to bring incremental value. We simplify and automate the provisioning. Then we bring in the visibility for performance monitoring and other pieces. But if they want a pure simple network, then that's what they're going to deploy. There's no value add. Where we really shine is the value add that we're providing in a mixed environment.
Also, Peter, don't forget that some people are deploying NSX on VLANs just for microsegmentation.
Yeah.
For parts, right.
Yeah. So they would use VLAN-based segments in NSX, in which case they would provide VXLAN-based transport.
Exactly.
You don't have to run NSX with VXLAN.
Yeah, I want to follow that up separately with you because I don't like NSX on VLANs. It seems like that's one of the things Cisco recommends when you integrate ACI with it, and it's kind of backwards. But
Well,
that's
Cisco
another-
does need to justify why you need ACI, but let's move on.
Yes, exactly.
Yeah, I really have only 5 minutes. I'm trying to, and I feel really awful shortchanging the discussion maybe on segmentation, but really quickly, of course, everything I said, because the fabric is geographically independent or geographically distributed, this automation is also available across multiple locations, right? And we don't really have a limit of 2 or 3, right? We actually have deployed it in up to 10 locations, 10 separate locations. So it's actually pretty interesting.
Partitioning?
Partitioning. Oh, by the way, okay, fine. This is a quick slide. VXLAN is important to us. Is maybe the way we would recommend you to build the network because you want to have layer 3 as the underlay, build scalable networks. It makes total sense. But boy, we found so many customers with 8 racks, 10 racks, 12 racks, which says, why do I need to go to BGP or OSPF and VXLAN? Can you give me these advantages on my standard traditional layer 2 network? And the answer is yes. So we can build a loop-free layer 2 environment and still have the operational simplification and the forwarding optimizations we discussed. Of course, there's no tunnel automation in there, right? Or overlay automation, but everything else is available. And again, this speaks to the freedom of choice of underlay and technologies you want to mix up. Now, I'm going to end up in big trouble here because we finally talk about segmentation, right? So segmentation, something very basic to begin with, right? So virtual network is a logical partition of the Pluribus fabric. Okay? The concept hopefully is clear. We do this through the concept of VNet, which is again short for virtual network. And the virtual VNet job is to group network objects. I keep using the language object, so it's what you heard before. A VLAN is an object, a VRF is an object, right? And you group them, and you can give control to a tenant or to the virtual network administrator of this set of objects. So the fabric administrator is in charge of designing policies and determine what resources are associated, allocated to which tenant. Once that is done, the VNet operator, the virtual network operator, has full control of those. Very important, the VNet is a distributed object. So the VNet is a construct which is distributed across the fabric. The very first question I heard today was about VDC, right? Although VNet is not a strict VDC, right? VNet is fully distributed across all the boxes. Imagine you have this top of racks, right? Leaf switches. You can partition this capability and these resources that goes from ports, physical ports, VLANs, VNI, VRFs, etc. Even VTEPs. You can, tunnels. You can also automatically and instantiate tunnels on a per tenant basis. Those are your virtual network built out of the common infrastructure. So you can say, hey, first 3 ports of the first 20 switches are going to take 100 VLANs, this group of VNIs, this set of VRF resources, and we call it application 1, right? And then you can say port 7251 on switch 1, 3, and 5, VLAN 5 and VLAN 79, that's another virtual network. So now the administrator of the virtual network, called the VNet manager, logs into its container that manages the network, more on that in a moment, and only has a tenant view of the infrastructure, right? But underneath, we actually manage through standard protocols the separation and isolation. Again, we don't invent anything new.
So as you go into configuration of your routing stuff, your configuration has unique semantics per switch, per tenant.
Per tenant, yes.
So how do you synchronize, desynchronize? How do you configure it from any device? How does it work?
Yeah, so we can associate a virtual router per tenant, right? And the virtual router is effectively a container that runs on our OS, runs on our switch. And this can be per tenant. I don't need to synchronize it, right? Then there are objects which are allocated by the fabric administrator, like VLANs, right? Which VLANs you can use is determined by the network administrator. But once you log into your system, you only have a view of your resources. And in these resources also you have routing resources.
But tenant in your definition is VNet object. It's not local to the switch, right?
Yeah, it's an object which is distributed across n switches, right?
So when things are common, I understand how you provision it. When they're unique per switch, per tenant.
Okay, then if they're unique, you have a level of flexibility of configuring it, right? Because you have your own virtual router as a tenant, so you can actually change some routing policies or security policies on a per tenant basis.
Do I have to be logged into this particular device, or it could be done on any device and then synchronized?
Oh, you're asking how it's done. Okay,
Yeah.
we have the concept of VNet Manager, which I'm going to examine in literally 2 slides. I'll show you how you manage your environment, okay, in a moment. Attributes of the VLAN, again, with one command, you provision a VLAN across n switches. You don't have to go into every switch and allocate the resources separately. You can do it from with one command from any switch. Independent management, right? So you can provision, every tenant can provision its own resources, the VLANs, the tunnels, the vRouters, etc. You have the full 4K VLAN ID available, so there's a concept of VLAN reuse. Coca-Cola tenant can have VLAN 1000 to 2000, and same for Pepsi, which lives in an adjacent tenant blue, for example.
How do you separate tenant by physical ports on the switches?
We can do physical ports, yes. Okay. We can also do physical ports, or there is also the concept of shared ports. At that point is the VNI, which is mapped to the tenant, which allows you to, at the data plane level, separate the VLANs belonging to 2 tenants.
Okay.
So we have shared ports and also physical port separation.
How about buffer space?
So buffer space, we don't carve a buffer, but we have QoS policies which are per tenant. We can apply QoS policies per tenant.
But potentially one tenant can overload another one, since buffer.
But we
is
can
common.
reserve bandwidth. We do reserve bandwidth. When I say QoS policy, you can have bandwidth reservation on a per customer, on a per tenant basis or per virtual network basis.
So you're doing basic policing at ingress,
Yes.
which doesn't prevent buffer from being overflown.
Yeah.
That's why we call them noisy tenants.
Yes.
Really quick, one important concept is actually how you manage this tenant, right? So the tenant manager is effectively just a portal, right? To manage and monitor the resources of a tenant. When I say just a portal, I really mean there is no state into the VNet manager. The state is all distributed in the fabric, which is actually one of the interesting aspects from a resiliency and high availability point of view. The VNet manager, however, once you log into this portal through SSH or REST, if you will, you have a tenant view of the network. So you only see the resources assigned to the particular tenant. And again, very important, this is a stateless container, which can sit on a Pluribus switch or can sit also on a server. Because it's stateless, this container can die, the node hosting the container die, there is no impact on the network because it's just a stateless container, just a portal. You lose connectivity to your environment. So it's not traffic impacting, but I can recreate this container anywhere in the fabric because the state is in the fabric. The knowledge of what a VNet is distributed in the fabric. And I can recreate this container on a physical host, server host, or I can recreate it on another switch in the fabric. Because it's the stateful nature of this container allows me to destroy and recreate them in a matter of few seconds on any part of the switching fabric.
Now
It can be a
this,
physical node, a physical server, or a physical switch.
now this is the per tenant manager,
Per tenant, yes, and you have N of these managers.
not the tenant manager, manager of
No,
tenants.
no, no. This is the tenant the virtual network manager.
Okay.
Yes.
So what are the limitations with regards to latency? And you're going into consensus-based distributed system. So you're as slow as your slowest contributor. What are the limitations?
In terms of configuring,
So you need all 100 members to say yes or no, right?
Yes.
It's logical. And so if 99th member takes half a minute to reply, you're
yeah,
screwed.
there are timers that once they expire, again, you roll back an operation, you don't perform it. But if everything goes well and you don't have these sort of latency issues or a node that goes offline, it's near instantaneous. It's the amount of time it takes to exchange packets.
On single LAN, for sure. You said you can extend it to another geographical location.
Yes.
What's your recommendation with regards to
Okay, you mean network latency?
Yeah.
So we tested, there's a customer in China which has 2 locations separated by, I think, 800 kilometers, right? There are 3 data centers, 800 kilometers. There's another customer in Europe which has 5 locations between Portugal and Spain. And the maximum diameter, I think, is in the order of 800, 900 kilometers in that case as well.
Yeah, and
So
running
in terms of
layer 2, that's perfect.
milliseconds, we think anywhere between 80 to 100 milliseconds is something we feel very comfortable.
RTT or one direction?
RTT. Beyond that, we really have not had a chance to experiment. But again, 80 milliseconds cover pretty wide geographical distance. Again, this manager, this VNet manager, is also fully highly available. Again, you can provision the container in active standby mode. If you don't want to lose access any second, you can provision 2 containers in hot standby mode, or you can resort to the previous mode I described. If the manager goes away for some reason, you just lose access to the network. You have to recreate it on the network. But again, there are customers which cannot accept that, right? So we also have the ability to synchronize these containers. Steve, do we wanna? I'll keep going. Last concept here is we discussed that, but I want to highlight that. We have some interesting degree of integration with vCenter. We do something which is, let's say, standard in the sense many other vendors do, which is provisioning ports and VLANs. But I think what's interesting, and I think we discussed that, is that we actually use VMware provisioning, driven provisioning, as an event to provision our overlay fabric completely automatically. So we extend a VLAN configuration across a tunnel. And if you actually happen to have a Pluribus leaf and Pluribus spine, and there is no overlay, we provision the VLAN even on the spine switches, end-to-end provisioning of network segments. We also have provisioning of multicast for vSAN transport, and we have just added support for NSX layer 2 gateway in the fabric. So again, it's another option you can use to provision VTEPs and definitely extend the NSX cloud, if you will, to bare metal workloads. This was my last slide.
Partitioning?
Partitioning.
Okay, what is the question of partition?
So, first of all, if your cluster is 100 nodes and 50 of them unavailable, most probably you won't take any actions.
Exactly. So we have to evict a node that doesn't respond, right?
If it's half of your network.
Okay, you have 5 locations, or let's say simply, you have 2 locations. 10 nodes here, 10 nodes here. The link between them goes down.
Right.
What happens next?
So you're supposed to build your network with high availability and resiliency.
If that's the answer.
Again,
Well, you thought you did. The carrier told you you did.
yeah. So in that case,
Well, with high availability, you decrease the probability of failure.
the
You don't bring
network,
it
the
to zero.
fabric continues to work. What you cannot do is provision the fabric.
Okay.
Okay. So
On either side, if there's any
yeah.
partition?
Again, look. Like I said, the fabric, what we call fabric, is nothing to do with the network. It's an overlay
logical
control
plane.
plane.
Yes, sure.
You interrupt that communication, the rest of the network goes, right? Because it's an application that is disjointed from the BGP, the OSPF, the span. So the important aspect is, look, you're losing your WAN connection. You have massive issues, right? Other than losing Pluribus control plane. What we want to ensure is that Pluribus control plane non-availability for certain nodes is not impeding the normal functioning of the network.
It's almost like
So sure, I can forward traffic
Yes,
through
absolutely.
what is now two
So you
different
go into
fabrics.
read-only mode.
but you cannot issue a configuration which span across the two networks.
Yeah, but what if I only lost, one node? I mean, I just have a majority there in the fabric is because one node fell out.
We wait. We wait until you restore that node. Again,
I've got to have 100% of the fabric 100% connected, or I can't
You
do
cannot-
any changes
yes,
to the fabric.
So this is how
It's an
consensus
atomic
based
system.
algorithms work.
That's it.
Okay.
If you're not comfortable because you have 100 nodes, a good strategy is creating two fabric of 50 nodes, right?
So you
for-
guys are always going to be consistent, always. You must have consistency.
Yeah, absolutely.
Yeah.
Absolutely. That's one of
Okay.
the premise of this architecture. We do recommend, for example, customers who have a leaf and spine. Put the leaf in one, the spine in other. Customers who have different pods. Put one pod in one management network, because anyway, the intercommunication happens through routers.
So you would manage the spine as an
Yeah.
entity and your leaves as an
Exactly.
entity.
Yeah,
Okay.
I mean, it's one of the design options. You want to have everything in one basket, then something goes wrong, right? Even when you do software upgrade, you can upgrade software on the entire fabric, but you may not want to do that, right? You want to take care of leaf.
If you'd advise people to have, possibly leaves as a domain and spines as a domain, where the heck is the DCI use case where you'd want to spread that out geographically?
The DCI is about extending layer 2 domains across.
Oh no, not anymore.
Across 5 locations, across 100 milliseconds. Yeah, that works really
It'll
well.
be fine, fine. Got it. So you're doing that just for people who want to do stretch layer 2. That's really the big use case.
Yeah.
Yeah.
Yeah, you can't stop some people.
They have to learn the hard way.
All right, good enough for now?
More questions?
Yes, sir.
Interaction with the routing stack.
Interaction with the routing stack.
So you provide the base OS. Routing stack
Oh,
runs
yeah.
an application, right?
Routing stack for us is a container, right? So I mentioned that before on a switch, you can run Quagga or FRR instance, right? And it operates as a container on a physical container on the switch, and you can have multiple of these containers.
So what is the boundary between application and the base OS?
It's a separate. The fabric runs in a separate process. It doesn't touch the Quagga
Let me
process.
rephrase my question. How do you program forwarding plane?
We program forwarding plane using Quagga. Basically, our OS listens to route RIBs, and then we program the hardware, right? So it's through our OS that we program the chip. Quagga, we listens to Quagga learning routes, and then we react and program.
How fast are you? RIP to FIP.
I don't have a number, so rather than throwing a number, I would like to go back and
Well, if it's
ask.
based on, I mean, it shouldn't matter that it's Pluribus there if it's that code underneath. It should match.
No, there's whole pipeline going from RIP through Quagga down to the chipset, right?
I'm just saying if they're using that code, that NetVisor shouldn't impact that time especially.
They increase the time.
Yeah.
Question by how much?
Yeah. By how much, I have to be honest, I don't know. I can ask engineering, and maybe you leave me your business card. I'll get back to you.
Thank you.